In this video, I'm going to teach you how to solve higher order non-homogeneous differential equation. So let's have an example. So we have this differential equation, and as you can see, the expression at the right of the equal sign is not 0. So this equation is not equal to 0, but it's equal to e to the x minus 1. So that makes it non-homogeneous. And how to solve it if it's non-homogeneous? So the general solution is solved in this way. So the y is equal to the complementary solution plus the particular solution. So we're gonna solve these two solutions and add them before you can get the general solution. So this complementary solution is the solution for homogeneous. So it's a homogeneous solution. So we're going to assume that the equation is homogeneous. And then later on we're going to talk about the particular solution and how to do that. So for now, let's solve the differential equation using by getting the complementary solution. So where we assume that it is homogeneous. That means we're going to make it equal to 0. And then get the auxiliary equation. We have r cubed plus 3r squared plus 3r plus 1 equals 0. So those exponents representing the order of the derivative of y. And then we'll try to find the roots of r. So we can take out the r squared, but then our problem is even if we take out the r squared, we cannot do something else. So factoring by grouping doesn't work in this case, and so we're gonna find some other ways to factor this. So we're gonna use synthetic division. So we'll put the coefficients 1, 3, 3, and 1, and we're gonna try, let's say we're gonna try -1, and so let's bring down the 1, and 1 times -1 is -1. Then combine 3 and -1 is 2, and 2 times -1 is -2. Combine 3 and -2, that's +1. 1 times -1 is -1. And combine 1 and -1, it's 0. So that means there's no remainder. So it means this -1 is part of the roots. Of course, it is expected that there are 3 roots because the exponent is to the power of 3. So there are 3 roots, so the one of it is -1. And then this 1 to 1 means r squared plus 2r plus 1 equals 0. So this is factorable, and we don't need to do synthetic division for this. So r, and then 1 and 1. So to check the pairing, if it's the right pairing, so we cross multiply. 1 times r is r, and then 1 times r is r. So if you combine r and r, that will be the 2r. So if it's the same with the middle term, that means the pairing is correct. So I'm gonna put the pair r plus 1 times r plus 1. So that's a factored form of r squared plus 2r plus 1. And then we're gonna solve for the r for each factor. We're gonna equate both factors. R equals -1 and r plus 1 equals 0, so r equals -1. So obviously it must be the same result. So the remaining two roots are r equals -1, and since we also have got the first root from the synthetic division, so we're going to put there r equals -1. So -1 multiplicity 3. So the root is repeated thrice. And so we're gonna have now the complementary solution, where since it is repeated, so it's gonna be c1 e to the negative x. The negative means -1x. Then c2x e to the negative x, and c3x squared e to the negative x. So we have x and x squared because it is repeated. That's the rule for repeating roots. Now let's find the particular solution of the differential equation. So let's have the given again, and then um, as you observe, the expression at the right side is colored differently. So I intend to do that because to emphasize that these two expressions have um, different general form. In other words, they have different family. E to the x um, is a natural exponential function, and negative x minus 1 is in the linear function or linear form. So they are different expressions, and we are going to separate them into two equations. So that means our particular solution will be separated into two. We will name it yp1 and yp2. So the yp1 will be this, and then we're going to find a particular solution of this equation. So to find a particular equation, so the yp1 is expected to be ae to the x. It's because that is the form of the expression at the right of equal sign. It's e to the x, so that means yp1 should be also ae to the x. And what is this a? It's the constant, and we're going to find that constant. So to find that constant, we'll continue, we'll derive y with the first derivative. So the derivative of ae to the x will be itself times the derivative of x, which is 1. And of course, it will be ae to the x. So it's going to be the same. And if you get the second derivative, it's still ae to the x. And if you get the third derivative, still it's going to be the same. So it's only up to the y triple prime because the expression on top is only up to y triple prime. And it is because we're going to substitute it to that expression. So we'll copy the equation. So let's substitute all, and it's going to be easy to substitute because it's all the same ae to the x. And then we're going to uh, take out or factor out e to the x because that's common to them. So that is easier for us to look at what to add. So we can actually add all a plus 3a plus 3a plus a. That's all in all 8a. So it will be 8a e to the x. Now this 8a must be equal to 1 so that that equation will be true. So where's that 1? The 1 is invisible at the right side, which is e to the x times 1. So if there's no 1, obviously we don't need to put 1 if it's only 1. And so 8a must be equal to 1. And then divide both by 8. So a is equal to 1/8. So since we already know what is a, then let us substitute from the yp1. That is yp1 is equal to 1/8 e to the x. So now we're going to solve the yp2. So for the yp2, we'll have this equation. So there's no more e to the x because that was for yp1. And then we'll have the yp2 equals the linear general form ax plus b, since, as I said, negative x minus 1 is a linear expression. So it's going to be ax plus b. And we will find what is a and b. So let's have the y prime derivative of ax plus b is a. Second derivative. So derivative of a is 0 because it's constant. And also derivative of 0 is 0. Now we're going to substitute. So 0 plus 3 times 0 plus 3a plus ax plus b equals negative x minus 1. And then we're going to simplify it. Let's remove those with zeros, and then let's arrange it where the one with x should be the written first. So it's going to be ax. And the next is 3a plus b. So let's equate those with this same with x. One with x is a, and the other side is negative 1 because it's negative x, so the coefficient of x is negative 1. It's imaginary 1. And then those without x, the 3a plus b and the negative 1. So since we know that a is -1, so let's substitute. And then we don't have enough space, so we're gonna put it on top. Let's copy it first, and then multiply 3 times -1 is -3, and then transpose -3, so it's gonna be +3, and then combine. So b is 2. So now we have a is -1 and b is 2. So we will solve now for yp2. So let's substitute. So yp2 is -1x plus 2. And we can remove the 1. So it's going to be yp2 equals -x plus 2. So let's have now the yp, which is yp1 plus yp2. So yp will be 1/8 e to the x plus the yp2, which is -x plus 2. So since we have the yp, now we can get the y, which is, or the general solution, so which is the sum of yc and yp. So y is equal to the yc, which is c1 e to the -x plus c2 x e to the -x plus c3 x squared e to the -x, that's the yc, plus the yp, which is 1/8 e to the x minus x plus 2. And that is the general solution. So let's have another example. So we'll have this. We have the third order differential equation, and we're going to find the general solution. The general solution will be in this form. Obviously, it must be the sum of the complementary solution, the yc, and the sum and the particular solution, the yp. And we don't need to separate the yp because this is just in one expression, 1 minus 4x cubed. So let us find the complementary solution, assuming that the equation is a homogeneous differential equation. So let's have the auxiliary equation, r cubed plus 2r squared minus r minus 2. And we're gonna find the roots of these r's. So we can use factoring by grouping. We're gonna group r cubed and 2r squared, taking out r squared, and also -r and -2, taking out -1. And then we can take out now the r plus 2 because that's common to the two terms. So r plus 2 times r squared minus 1. And then r squared minus 1 can be factored using difference of two squares because 1 is 1 squared. So it's going to be r plus 2 times r minus 1 times r plus 1. And then I'm going to solve the roots of these three factors. So r plus 2 equals 0, so r is -2. For r minus 1 equals 0, r is 1. And for r plus 1 equals 0, r is -1. So since we have the roots, then we can have now the complementary solution. So yc is equal to c1 e to the -2x, that's for the root -2, and c2 e to the x, that's the root 1, and c3 e to the -x, that's the root for -1. And that's the complementary solution. So next we're gonna find the particular solution. So let's go back to the given, and then we're gonna have the yp. Yp is in this form because it's to the power of 3, so we're gonna start with the ax cubed. So it's gonna be ax cubed plus bx squared plus cx plus d. So we don't know what is this a, b, c, and d, and we're gonna find that those constants. So let's have the y prime. Let's derive the yp. So ax cubed is 3ax squared. Derivative of bx squared is 2bx. Derivative of cx is c. And derivative of d is 0, so you don't need to put that. And then let's derive again to get the y double prime. So derivative of 3ax squared is 6ax. Derivative of 2bx is 2b. And derivative of c, which is a constant, is 0. So you don't need to put that. And then again, we're gonna derive again the y double prime to get the y triple prime, because our expression is up to the y triple prime. So derivative of 6ax is 6a, and derivative of 2b, since it's constant, then it's gonna be 0. And so let's substitute from the given. Let's substitute everything. So it's gonna have 6a and then plus 2 times the y double prime minus the y prime. That's the given. And then the minus 2 times the ax cubed. So that's the yp, or the y, which is equal to 1 minus 4x cubed. And then we are going to distribute whatever we can distribute, 2 times 6 and 2 times 2. So we'll have 12ax and 4b. And also we're going to distribute the negative sign. So the 3 becomes negative 3, 2 becomes negative 2, and c becomes negative c. Also for negative 2, we'll distribute that. So it becomes negative 2ax cubed, negative 2bx squared, negative 2cx, and negative 2d. So everything is just about distributing. So let us copy the last part because we don't have enough space. So as you can see, I colored those terms with the same coefficient. Those with x color red, and those without x as a color royal blue. Those with x squared color orange, and then the one with the x cube is color green. It's only one term with the x cube. And then we're gonna arrange it such a way that arrange it in order of the exponent, and also we're gonna put together those with the same coefficient, so it's easier for us to factor out. So let's factor out the x squared. So we're left with negative 3a minus 2b. Let's factor out the x. So we have 12a minus 2b minus 2c, and the one the without the x is at the bottom. So I intend to do that so that it's easier for us to equate whatever uh, to be equated. So like here, the x cubed has negative 2a, and at the other side of equal sign, the x cubed there has negative 4. So you can equate them and solve for a. So divide both by negative 2, so a is 2. And also for the x squared, since there's no x squared at the right side of equal sign, so just equate negative 3a minus 2b with 0. And then solve. So negative 3 times 2, because a is 2, that's negative 6 minus 2b equals 0. So transpose and then divide by negative 2. So b is negative 3. And then for x, so we have 12a minus 2b minus 2c equals 0 because there's no x at the right side. And so substitute since we know the a and b. And let's multiply 24 and 6 minus 2c equals 0. So let's combine 24 and 6, that's 30. And then transpose, then we can divide both by negative 2. It will be c is 15. And lastly, the one without the x, we have 6a plus 4b minus c minus 2d and equals 1 because the one without the x at the right side is 1. And so let's substitute with those constants that we have. We have a is 2, b is negative 3, and c is 15. And then let's multiply 6 times 2 is 12, 4 times negative 3 is negative 12, and then we combine 12 and negative 12 is 0, and then transpose negative 15, so 1 plus 15 is 16. Then divide negative 2d and 16 by negative 2. So let's copy it. We don't have enough space. And then divide negative 2. D is negative 8. Now since we have completed all the constants, so let's list it all. We have a is 2, b is negative 3, c is 15, d is negative 8, and we're gonna substitute here in the yp. So substitute it all, and we have yp equals 2x cubed minus 3x squared plus 15x minus 8. And then we're gonna go back to our general solution, y equals the yc plus yp. So now y is equal to the yc c1 e to the negative 2x plus c2 e to the x plus c3 e to the negative x plus the yp. The yp is 2x cubed minus 3x squared plus 15x minus 8. And that is our general solution. So let's have another example. We have this um, fourth order, and as you can see, we have initial conditions or initial values. So it means we're gonna find the exact value of the constant. So it is expected that the C1, C2, and so on will be having a value. So let's have the C first. So complementary solution, because this is a non-homogeneous differential equation. So we're gonna have the YC and the YP. So let's assume that it is homogeneous. Let's remove the 10e to the negative 3x. Let's make it 0. And then we'll have the auxiliary equation. R to the fourth minus 5r squared plus 4 equals 0. So let's find the roots of this. So let's factor r squared and r squared, and negative 4 and negative 1, that's positive 4. So to check if it's the correct pairing, let's cross multiply, and this will be negative 4r squared and negative r squared. So combining these two will be negative 5r squared, which is the middle term, and that is correct. So that means we're gonna have now the correct pairing, r squared minus 4 and r squared minus 1. And so we're gonna factor further, because this is difference of two squares. We will have r minus 2 times r plus 2, r minus 1 times r plus 1. And then we're gonna have now the roots, r equals 2, and for r plus 2 it's r equals negative 2, r equals 1, and r equals negative 1. So of course every factor will be equal to 0, and you're gonna transpose. And so we'll have uh, the complementary solution, the yc, which is equal to c1 e to the 2x, that's for the root 2, c2 e to the negative 2x for the root negative 2, c3 e to the x, that's for the root 1, and the c4 e to the negative x, that's for the root negative 1. So that's our yc. Now for the yp, so we're gonna go back to the given, and then we're gonna have the yp, which is equal to whatever is the form of the right expression, which is 10e to the negative 3x. So the expected yp will be ae to the negative 3x. So we don't know what's the constant a, and we're gonna solve that. So let's have the y prime of ae to the negative 3x. That's ae to the negative 3x times the derivative of the exponent, negative 3. So it's gonna be this, and then the second derivative. So the same procedure, and let's multiply negative 3 times negative 3 is positive 9. Third derivative, or that y triple prime. So same procedure, and we're gonna multiply the negative 3 times 9, negative 27. And the fourth derivative, so again it's the same procedure because it's e to the negative 3x. So let's multiply negative 3 times negative 27 is positive 81. And those are the things that we are going to substitute. So let's have the given, and let's substitute. So there you go, we have all 81 ae to the negative 3x, that's for the y to the fourth derivative, and negative 5 times the y double prime, 9ae to the negative 3x, plus 4 times the y, which is ae to the negative 3x. So based on the given, there's no y prime and there's no y triple prime, so we will not gonna use it. And so let us simplify further. Negative 5 times 9 is negative 45, and 4 times a is 4a. So let's copy the last part, and then we are going to factor out e to the negative 3x, so that it's easier for us to combine. So let's combine. 81a minus 45a plus 4a is 40a, and so to make this equation equal, the 40a must be equal to 10. So 40a is equal to 10. Let's solve. Divide 40 both sides, so a is 1/4. So since we know the a, which is 1/4, let's go back to our yp and let's substitute. So yp is 1/4 e to the negative 3x. So now we have the yc and the yp, so we can get now the y for the general solution. So the y is equal to c1 e to the 2x, c2 e to the negative 2x, plus c3 e to the x, plus c4 e to the negative x, which is that's with the yc, the whole thing, plus the yp, which is 1/4 e to the negative 3x. So that is the general solution. But we have the given initial values. That means we're going to find the c1, c2, c3, and c4. And so let's have first let's substitute based on the given y of 0 is equal to 1. That means if we substitute x by 0, y is 1. So let's substitute, and then let's solve. 2 times 0 is 0. So all the numbers multiplied by 0 becomes 0. And then all the e to the 0 becomes 1. Any number to the power of 0 is 1. And then let's multiply. So the c1 is times 1 is just itself. So any number times 1 is just itself. And then we're gonna transpose to 1/4. So 1 minus 1/4 is 3/4. And that's the first equation that we have. And we need that later. So let's have the general solution, and we need the y prime, because that is part of the initial values or initial conditions. So let's derive. So the y prime is c1 e to the 2x times 2. That's for the first term. And it's actually the same with the rest. It's just times with the derivative of the exponent. And then let us simplify further. So we're gonna put the constants to the left side. So c1 e to the x to the 2x times 2 will be now 2c1 e to the 2x. And the same as the negative 2, it will be now at the side of the c2. The 1 for the c3 will be gone because it's just an imaginary 1 at the right of c3, I mean at the left of the c3. And the negative 1 will be transferred. It will be now negative c4. And then the negative 3 and 1/4 will be multiplied, so it will be now negative 3/4. So that is our y prime. And then we will substitute based on the initial values. So according to the given, if x is 0, then the y prime is 0. So let us multiply the numbers with 0, it becomes 0. And every e to the 0 will become 1. So let's copy the last part, and then let's continue because we don't have no space. So let's multiply any number by 1 is just itself, and transpose the 3/4. So we have this now. This is um, the second equation that we needed to find these constants. So let's have now the y prime. This is the y prime that we have solved, and we need this to find the y double prime. So we're gonna derive this. So when you derive 2c1 e to the 2x, it will be multiplied. It will be the same, but it will be multiplied by the derivative of the exponent, which is 2. So the same as to the negative 2c2 e to the negative 2x, it will be itself times the derivative of the exponent, which is negative 2. And the same as to the rest of the terms. And then we're gonna multiply the values. 2 times 2 is 4, negative 2 times negative 2 is positive 4, and the 1 will be not necessary to put, and then negative 1 will be multiplied with negative C4, it will be positive C4. Negative 3 times negative 3 fourths is positive 9 fourths. And so this is the y double prime. And then we are going to substitute according to the given initial values. So based on the given, if x is 0, then the y double prime is 0. So we have substituted there, and we're gonna multiply those numbers with zeros. So and multiply all the number with zeros, so it becomes 0. And then we change e to the 0 into 1. So let's copy the last part and let's multiply this by 1. So it's just itself, and transpose the 9 fourths. So it's going to be negative 9 fourths. So this is another equation that we needed later to solve the constants. Now let's have the second derivative, the y double prime, where we have solved a while ago. And we need this to find the y triple prime, meaning we're going to get the derivative of this. So y triple prime will be, so the same procedure, we're going to, it's going to be itself times the derivative of the exponent. So that's going to be easy when you're deriving an exponential expression. And so we are going to multiply the values. 4 times 2 is 8, 4 times negative 2 is negative 8, and 1 times c3 is c3, negative 1 times c4 is negative c4, and negative 3 times 9 fourths is negative 27 fourths. So this is our y triple prime. And then we are going to substitute based on the given initial conditions, where if x is 0, then the y triple prime is 0. So let's multiply all the numbers with 0. It becomes also 0. So every e to the power will be to the power of 0. And then those e to the 0 will become 1. So any number to the power of 0 is 1. Then we'll copy the last part to have extra space, and then multiply all the numbers by 1, so it becomes itself, and then transpose the negative 27 fourths. So this is now the equation that we needed. So we have another equation to use later for our for the values of our constants. So let us collect all the equations that we have come up. We have 3 fourths equals c1 plus c2 plus c3 plus c4. 3 fourths equals 2c1 minus 2c2 plus c3 minus c4. We have negative 9 fourths equals 4c1 plus 4c2 plus c3 plus c4. And we have 27 fourths equals 8c1 minus 8c2 plus c3 minus c4. So those are the equations that we needed. And we're gonna use simultaneous equation. So we're gonna use elimination method to solve, to find the values of c1 up to c4. So let's pair the equations. So I'm gonna pair the orange and the yellow green because they have the same signs of the constants. They are all positives, and it's gonna be easier for us to cancel some constants that we want to cancel. So in this case, I want to cancel the c1 and c2. So I multiply the 1 on top with negative 4. And so it will be negative 4 will be distributed. So negative 4 times 3 fourths will be negative 3. And c1 times negative 4 is negative 4 c1, and so on up to negative 4 c4. So let's copy the green equation and then combine. So if you combine negative 3 and negative 9 fourths, it will be negative 21 fourths. And if you combine the c1s and the c2s, it will be 0. And combining negative 4 c3 and c3 will be negative 3 c3. Also with a negative 4 c4 and c4 will be negative 3 c4. So let us reduce this. So divide all by negative 3, it will be positive 7 fourths equals c3 plus c4. Then we will use the the violet and the blue ones, because they're having the same signs of their constants. The C2 and C4 are negatives, C1 and C3 are positives. It's easier for us to cancel this. And I'll multiply this by -4 so that the C1 and C2 will be cancelled. So distribute the -4, it will be 3/4 times -4 is -3, -4 times 2 is -8, -2 times -4 is +8, -4 times C3 is -4C3, and -4 times -C4 is +4C4. Then copy the blue equation and then combine. So if you combine -3 and 27/4, it will be 15/4. And then combining C1 and C2 will be 0. And combine -4C3 and C3 is -3C3. +4C4 and -C4 is +3C4. And so let's reduce. This can be divided by -3. So 15/4 becomes -5/4. And the -3C3 becomes C3, and +3C4 becomes -C4 because we divide all by -3. So let us pair those equations that we have come up. The 7/4 equals C3 plus C4, and the -5/4 equals C3 minus C4. Because we combine them, the C4 will be gone, and we can solve for C3. So you'll just combine them directly. So combining C4, I mean 7/4 and -5/4 is 1/2. C3 and C3 is 2C3, and the C4 is 0. And then divide both by 2, it will be C3 equals 1/4. So now since we have already the C3, then we can get the C4 using either of the two equations on top. But also to review if we are doing it right, we better substitute to both sides, to both equations, so that we can check if we are doing it correctly. So C3, we're gonna substitute, it's 1/4, and we're gonna solve for C4, transpose 1/4 to the other side. Then combine, you'll get 3/2. So the C4 should be 3/2 in the other equation. So let's see if it's the same. So let's substitute C3 by 1/4. Then transpose 95/4 minus 1/4 is -3/2. And then divide both by -1. C4 is 3/2. So C4 is 3/2. So next is we're gonna pair the yellow equation and the violet, because they contain a C1 and C2, where C2 are opposite signs. And C3 and C4 doesn't matter because we are just going to substitute them since we already know the values of C3 and C4. So let us substitute. So C3 is 1/4 and C4 is 3/2. And there you go, we substitute, and then we are going to transpose to the other side to both equations. So 1/4 becomes -1/4, 3/2 becomes -3/2. And then we are going to combine the the constants. 3/4 minus 1/4 minus 3/2 is -1, and then 3/4 minus 1/4 plus 3/2 is +2. So we have this now, and then we can still simplify the violet equation because it all the terms contains 2. That means we can divide all the terms by 2. So let's copy the yellow, and then since all the terms are divided by 2, it is now 1 equals C1 minus C2. Then we can combine directly so that the C2 will be 0. So -1 plus 1 is 0, and C1 plus C1 is 2C1. Then to get the C1, we divide both by 2. So it will be C1 equals 0. Now to get C2, we can use either of these equations. These are the previously added equations, the yellow and the violet. We need this to get the C2. So we're gonna solve both to make sure that we are getting the correct C2 value. So let's substitute the C1. C1 is 0, and then so C2 is negative 1. And let us try to the same procedure to the violet, and let's see if its C2 is also negative 1. So let's change C1 into 0, and then so 1 equals negative C2. Then divide both by negative 1. So we have C2 equals negative 1. So that means C2 is really negative 1. So let us list all the values of the constants. We have C1 is 0, C2 is negative 1, C3 is 1/4, C4 is 3 halves. And we're gonna put it all in our general solution. So let's substitute. We have this now. We change all the C1 up to C4. And to simplify further, we have y equals. So the 0e to the 2x is gone because it's times 0. And then the negative 1 we'll just write negative instead because 1 is just an invisible 1 at the side of the e. Then we have plus 1/4 e to the x plus 3 halves e to the negative x plus our yp, which is 1/4 e to the negative 3x, and that's the final answer. So let's have another example. We have a fourth degree differential equation, and there's a given initial values where our expression at the right side is a trigonometric function 90 sine 4x. So let's get the complementary solution. We have this where it is equal now to 0 to make it homogeneous. Then the auxiliary equation, which is factorable with r squared and 4 and 1. And then we cross multiply to check the pairing. So it will be 4r squared and r squared, which is a sum of 5r squared, which is correct. So the factors are r squared plus 4 and r squared plus 1. And so we're going to solve for the roots. So r squared equals negative 4, and take the square root of both sides. R is plus and minus 2i. So the same as the r squared plus 1. Transpose, get the square root of both sides, and r is plus and minus I. And so because we have this, then we're going to have our complementary solution for complex roots. So these are our roots, and here's our complex solution. E to the 0x, because there's no real root for 0 plus minus 2i, it's only 0. So C1 cosine 2x plus C2 sine 2x. So the 2 is in the imaginary part. Plus e to the 0x, this is for the other root, the other r, the 0 plus minus I. C3 cos x plus C4 sine x. So to simplify, we change e to the 0 into 1, and this is our complementary solution. And then we need now the particular solution. So to find the particular solution, let's have the given, and then we're gonna have the yp, which is, since it is 90, it is sine function, then we're gonna have the yp cosine and sine. So you might ask, why is the cosine there if the expression is just sine? So actually you can actually try that just putting a sine 4x, but then later on you will have some problems. You're gonna encounter some problems where you're gonna stop and uh, you cannot continue solving. It's because the derivative of sine is cosine. So because there is sine, the cosine will always appear because you'll take the derivative of that expression. So that's why you always pair the sine and the cosine. So if it's sine, then you're gonna be having this expression a cos and the b sine. Even if it's cos, also the same expression, cosine and sine. So it's either sine or cosine. It's the same expression for the yp. So let's take the derivative. The y prime of this derivative of cosine is negative sine. Of course, the chain rule. Derivative of 4x is 4. And so for the second term, derivative of sine is positive cosine. And then we're gonna arrange it, so it's gonna be negative 4a and positive 4b. So let's take the second derivative. So the same procedure, derivative of sine is cosine, derivative of cosine is negative sine, and we will multiply the constants. 4 times 4 is 16 for both. Then for y triple prime, take the derivative of the y2 primes. So um, derivative of cosine is negative sine, so the negative times negative is positive. It becomes positive now. Then derivative of sine is cosine, so the negative sign will not change because it's derivative of sine. And then we'll multiply the constants. 4 times 16 is 64 for both. And last, we're gonna have the fourth derivative because our expression is up to fourth derivative. So the derivative of sine is cosine, and derivative of cosine will be negative sine. So the second term will be now positive because it is the derivative of cosine. So let's multiply the constants. 4 times 64 is 256 for both, and then we will substitute. So from the given, we will substitute all. For the y4, we have 256a cosine 4x and 256b sine 4x. For the y double prime, we have negative 16a cos 4x and negative 16b sine 4x. It will be multiplied by 5. And for the y, negative 4a sine 4x plus 4b cos 4x, it will be multiplied by 4 based on the given. So we actually didn't use anymore the y triple prime and the y prime because it's not given. And then we're gonna simplify this. Let's copy first because we don't have enough space, so we transfer it on top. And here you go. We distribute the 5 and the 4. So 5 times 16 is 80, and also for 4 we distribute. It becomes 4a and 4b. And then we are going to combine like terms. So as you can see, the cosine are colored with dark green, and the light green colored are the one with the sine 4x, because we can combine them. So combining them will result to 180a cos 4x, and for sine it will be 180b sine 4x. So we are going to pair those cosines, but since there's no cosine to the right side, so it's going to be 180a equals 0. Divide both by 180, a is 0. And for sine, so 180b will be paired with 90. Divide both by 180, b is 90 over 180. Reduce it, b is 1 half. And so our yp now can be changed into real numbers. We have 0 and 1 half for a and b. So 0 times cosine 4x is gone because it's times 0. So what's left is 1 half sine 4x. So that is our yp. So let's have now our general solution. Y equals yc plus yp. So our yc is c1 cos 2x plus c2 sine 2x plus c3 cos x plus c4 sin x plus the yp 1 half sine 4x. And we are going to substitute based on the given initial values. So the initial values given is stating that if x is 0, y is 1. So we substitute there, and then we're gonna multiply 2 times 0 will be 0, and also 4 times 0 is 0. And then we are going to get the cosine of 0, which is 1. Also sine of 0 is 0. Then we're gonna multiply, all those multiplied by 0 will be gone, so what's left is c1 and c3. So we have the first equation that we needed later to be used to find the constants c1 up to c4. So next is we are going to get the y prime. So from the equation that we have, the y, so we will derive this to get the y prime. So derivative cosine is negative sine, and derivative of sine is cosine. And of course, we apply the chain rule. So we'll simplify further. So we'll put the constants to the left side, so that it will not be mistakenly multiplied to the angle of the trigonometric functions. And so we'll substitute based on the initial conditions. When x is 0, then y prime is 2. Then multiply those numbers with zeros, the angles I mean. So let's multiply that. And then sine of 0 is 0 and cosine of 0 is 1. Then all those times 0 will be gone. So what's left is 2c2 plus c4 and plus 2. So we can transpose the 2 because it's constant. So it becomes 2 minus 2, which will give us 0. So this is another equation that we needed later. Then using the y prime, we can have the y double prime by deriving this equation. So let's derive. So same procedure, but the numbers are getting bigger. Derive the sine, which is cosine, and derive cosine, which is negative sine, to all terms. And then we have this. So let's multiply the constants. 2 times 2 is 4, and 4 times 2 is 8. And then we'll substitute based on the initial conditions. If x is 0, then the y double prime is negative 1. Then multiply the angles. So it's 2 times 0 is 0. Also 4 times 0 is 0. Then we get the cosine of 0, which is 1, and sine of 0 is 0. And all the numbers multiplied by 0 will be gone. So we're left with negative 4c1 minus c3. Then we divide by negative 1 because they are all negative, so that it is all positive. So anyway, you can leave it as negative, but I am more comfortable if the values are all positive. Now using the y double prime, we can have the y triple prime by deriving this equation. So let's derive this. So it's the same procedure deriving like the previous primes. So we have the y triple prime. We have 8c1 sine 2x minus 8c2 cos 2x plus c3 sine x minus c4 cos x minus 32 cos 4x. So observe that the numbers, that means the functions are the same. It's just sine and cosine interchanging, but the numbers are getting bigger and bigger. So let's substitute based on the initial values given. So according to the given, if x is 0, then the y triple prime will be negative 32. So we substitute, and then we are going to multiply the angles. So you observe that it becomes 0. And then sine of 0 is 0, cosine of 0 is 1. So we change it all. Then all multiplied by 0 becomes 0, or it is gone already. And then we are left with negative 8c2 minus c4 minus 32. Then we'll transpose that negative 32 to the other side. So it is 0 minus 8c2 minus c4. So since it's negative, then we'll divide by negative 1 to make it positive. So anyway, 0 divided by negative is still 0. So let us collect all the equations that we have come up. We have 1 equals c1 plus c3, 0 equals 2c2 plus c4, 1 equals 4c1 plus c3, and 0 equals 8c2 plus c4. And so we are going to pair now to do elimination method. We're gonna pair the green and the yellow. I guess it is yellow because I want to cancel the c3. So I'm gonna multiply this by negative 1. So if we combine the c3, it will be 0. So let us multiply, distribute the negative 1 and copy the previous equation. Then we combine. So negative 1 plus 1 is 0. Negative c1 plus 4c1 is positive 3c1. So we'll divide both by 3, so it becomes 0. So c1 is 0. Now since we know that c1 is 0, then we can solve for c3 in either of these equations. So we'll use these equations both to check, to get the c3 and also to check if our solution is doing it well. So let's substitute c1 into 0 and c3 is 1. How about in the other equation? Let's try to substitute. So 1 equals 0 plus c3. So c3 is still equals 1. So it is correct. And then we're going to pair these equations, the green and the orange. And we are going to multiply it by negative 1 so that the c4 will be gone. So let us distribute and copy the orange and then combine. So 0 and 0 is 0. Negative 2 plus 8 is 6. Divide both by 6, it will be 0. So C2 is 0. Then to get the C4, we can use either of these two equations. So it's just both. Let's just use both equations. So substitute 0 equals 2 times 0 is 0. So C4 is also 0. How about on the other equation? 8 times 0 is 0. C4 equals 0. So C2 is 0 and C4 is also 0. And so we have all the constants that we needed. We have C1 is 0, C2 is 0, C3 is 1, and C4 is 0. And we are going back to our general solution where we can substitute our constants. So we change all the C1 up to C4 based on what we have computed. And so all the terms multiplied by 0 will be gone, and we're left cosine x plus 1/2 sine 4x. And that is the final answer. So let's have another example. We have this second order differential equation, and we have given initial values where the initial values are only uh, the basic y, so it's not the y prime. So it's y of 0 equals 2, so it means if x is 0, y is 2. And also if x is pi halves, y is 0. And we're gonna use both to find the constants later. So for now, let's find the complementary solution. So let's make this first homogeneous by making 2e to the negative 3x 0. And then let's have the auxiliary uh, equation, and let's find the roots. Now this is not factorable because the factors for r squared is only r and r, and for 17 it's only 17 and 1 because it's prime, and you cannot have 8r. So the alternative method to do is to use the quadratic formula. So you have negative b plus and minus square root of b squared minus 4ac all over 2a. So let's substitute where a is 1, b is 8, c is 17. And then let us simplify further. 8 squared is 64. 4 times 1 times 17 is 68. Then we subtract 64 and 68 is negative 4. Square root of negative 4 is 2i. So let's separate the 2 with negative 8 over 2 and 2 over 2. Simplify that. 8 halves is 4 and 2 halves is 1. So our root is negative 4 plus and minus I. So we can have now the complementary solution where this format is for complex roots. We have e to the negative 4x. It's negative 4 because of the real part of the root, negative 4, times c1 cosine x. So it's only cosine 1x because of the 1i. So cosine x plus c2 sine x. So that's the complementary solution. And we need to solve now the yp. So now let's solve the yp. Let's have the given, and the yp should be in this form based on the given in the right side of the equation, 2e to the negative 3x. So yp must be also ae to the negative 3x, and we're gonna find the a. So let's have the y prime. Let's derive. So derivative of ae to the negative 3x, it will be negative 3ae to the negative 3x. Then find the y double prime, which will be 9ae to the negative 3x. And so let us substitute from the given, substitute all for the y prime, y double prime, and the y. And then we are going to simplify. 8 times negative 3 is negative 24. 17 times a is 17a. And also we can combine them. 9a minus 24a plus 17a, it's all 2a. And because of this, it means the 2a must be equal to 2, so that it will be a true statement or a true equation. So 2a is equal to 2. What is a? Divide both by 2. A is 1. So because a is 1, we can have our yp. So let's substitute a by 1. So yp is e to the negative 3x. So let's have our general solution since we have already the yc and the yp. So y equals yc plus yp. So our yc is e to the negative 4x c1 cos x plus c2 sin x, and our yp is e to the negative 3x. Now we are going to use the initial values given. So let's substitute. If x is 0, y is 2. So let's uh, simplify this. E to the 0 is 1, and cosine of 0 is 1, sine of 0 is 0. And then c2 is gone because c2 times 0 is 0. So what's left is c1 plus 1. Then transpose. We have 2 minus 1 is 1. So c1 is 1. So again, we're gonna use the general solution that we had a while ago. And then since we already know the c1, so we'll change it into 1 because c1 is 1. Or you may not write it. So it's cosine x. And then we are going to use the other given initial condition that if x is pi halves, then y is 0. So we substitute it all, and now we multiply. Negative 4 times pi halves is negative 2 pi. And also cosine of pi halves is 0, sine of pi halves is 1. And negative 3 times pi halves is negative 3 pi halves. So 2 times 0 is 0, c2 times 1 is 1. So we're left with c2 e to the negative 2 pi. And we transpose the e to the negative 3 pi halves. So it becomes negative. Then to solve for c2, we divide both by e to the negative 2 pi. So let's transfer it on top and let's divide. So when you're dividing the same base, we are going to subtract the exponents. So negative 3 pi halves minus negative 2 pi. So it will be negative and negative becomes positive. So combining the negative 3 pi halves and 2 pi, it's negative pi halves. So our C2 is negative e to the negative pi halves. So let us gather our C1 and C2. So C1 is 1 and C2 is negative e to the negative pi halves. And let's substitute y equals negative 4x times the C1, which is 1, and C2, and our yp is e to the negative 3x. So our final answer will be y equals e to the negative 4x cosine x minus e to the negative pi half sine x plus e to the negative 3x. Now let's have another example. So I guess this will be the last example for this topic. So we have this, and you can see different variables. We have x and the tau. So it's d squared x over dt d tau squared. So instead of saying tau, we'll just use t because it's simpler to read compared to tau. So this d squared x over dt squared plus 4 dx over dt plus 3x equals e to the negative 3t. And there's a given initial values. If x is 1/2 and dx over dt equals negative 2 at t equals 0. So now based on the given, it looks hard, it looks complicated because maybe you're unfamiliar with the looks of this given. But let's make it simpler to look at. So because it's just actually the same to the previous examples, but the variables are just changed. Instead of y, it becomes x. Instead of x, it becomes the tau or the t. So let's just change it. The second derivative will make it x double prime, and the first derivative will be x prime. And also for the initial values, it just means x of 0 is 1/2, and the first derivative of x of 0 is negative 2. So now it looks easier to understand. And so let us find now the complementary solution. So let's make it homogeneous and use the auxiliary equation. So factors of r squared and factors of 3. Then we cross multiply. We have 3r and r, which is, if you combine them, it's gonna be 4r, which is correct pairing, indicating that it's correct pairing. So the pairs are r plus 3 and r plus 1. And so we're gonna solve for the roots. R plus 3 equals 0 and r plus 1 equals 0. So r is negative 3 and r is negative 1. So let's have now the complementary solution. So instead of yc, it's now xc because there's no y in our variable, it's x. So xc is equal to c1 e to the negative 3t for the negative 3 root, and c2 e to the negative t for the negative 1 root. That is our complementary solution. Now let us find the particular solution of our given. So this is our given. Now we're gonna find the particular solution, the xp. So observe that we put here, instead of ae to the negative 3t, I put at e to the negative 3t. So there is a t in between a and e. So why did I put it there? Why not the same as the previous examples, that it's only ae to the same exponent? So I intend to do that because the given e to the negative 3t has the same uh, exponent as the complementary solution. It contains also e to the negative 3t, if you can remember in our complementary solution. The problem with that is, if we are going to have our general solution, the xp and the xc will be combined, which is not good for our solution. It will create a problem. And so to avoid combining the xp and xc, then we're gonna put a variable t. So if it's x, then we'll put x, but this time it's tau or t. So that makes it possible to solve. So you only do that if the given expression has the same exponent with the complementary solution. It's the same e to the negative 3t. So that means they are like terms and they will be combined as we have the general solution. So we need to avoid that. And so observe that I put different colors for at and the e negative 3t because if we are going to get the first derivative, we need to do the product rule. So that it's easier for you to look at the two groups, the u and the v. U is for at and the v is e to the negative 3t. So let's have the first derivative. So copy the at first and then derive the v, the e to the negative 3t, and then plus copy the e to the negative 3t, and then derive the 80. So derivative of 80 is 8. And so let's arrange it. So we're gonna put the negative 3 to the left side of a, and also the a, put it at the left side to e, so it's easier to look at. And then we're gonna have now the first we're going to factor out the ae to the negative 3t, so that it's easier for us to derive to get the second derivative. So let's get now the second derivative, where the u is the red colored uh, numbers, ae to the negative 3t, and the v is negative 3t plus 1. So we derive the red one, we copy the red one, and then we derive negative 3t plus 1, so the answer is negative 3. Plus, then we copy the v, so negative 3t plus 1, and derive the ae to the negative 3t. So the derivative is ae to the negative 3t times negative 3. Then simplify it. So we put the negative 3 at the side, and also for the other term, the second term. And then we take out negative 3ae to the negative 3t because it is common to both terms. So what's left is 1 plus negative 3t plus 1. And then we combine 1 plus 1 is 2, so it becomes 2 minus 3t. So this is now the second derivative of the xp. And so we are going to substitute everything for the x prime and the x double prime. So here it is. And then we are going to simplify further. So what we did here is we take out the ae to the negative 3t because it is common to every term, so that it is simpler to manipulate the one inside the parentheses. And so let's distribute the values. Distribute the negative 3 and positive 4. It is now negative 6 plus 90. And 4 times negative 3 is negative 12t. 4 times 1 is 4. And so we combine the negative 6 and the positive 4, it's negative 2. While the 90 minus 12t plus 3t is 0. So it's gone. And then we are going to arrange it such a way that negative 2 will be at the left side of a, so that it's easier to look at. And now the negative 2a should be equal to 1 because these two are, the negative 2a and the 1 are both coefficients of e to the negative 3t. So let's divide both by negative 2. A is negative 1/2. So since a is negative 1/2, let's go back to our xp, which is a t e to the negative 3t. So substitute negative 1/2 there, so we'll have the xp, which is negative 1/2 t e to the negative 3t. So let's have our general solution. So x equals xc plus xp, or the complementary solution plus the particular solution. So our complementary solution, we have c1 e to the negative 3t plus c2 e to the negative t. And our particular solution is negative 1/2 t e to the negative 3t. So this is the thing that I was talking about, that cannot we cannot leave the particular solution as e to the negative 3t because it will be combined to the first term, which is where they are having like terms. So that's the reason why we added t to the term. And so since we have the general solution, let's use the initial values given. So the initial conditions given is x equals 0. T equals, if t is equal to 0, then x is 1/2. So we substitute everything there and multiply negative 3 times 0 is 0, and then e to the 0 becomes 1. So what's left is c1 and c2 because negative 1 half times 0 becomes 0. So this is the first equation we needed. And then we will have this expression again, the equation, the general solution, because we needed the x prime. So we'll derive this. So as you can see, I intentionally colored negative 1 half t red and e to the negative 3t green, indicating that that's the u and the v, because we need to use product rule for this. So no problem with the first and the second term because it is just simple to derive. So derivative of c1 e to the negative 3t is just itself times the derivative of negative 3t, which is negative 3. And so with the rest for the second term. But for the third term, we use the product rule. Negative 1 half t times the derivative of e to the negative 3t. Plus we copy the e to the negative 3t and then we derive negative 1 half t, which is negative 1 half. Then we simplify. So we just put the negative 3 at the side of c1 and then we put the negative 1 at the side of c2 and then we multiply negative 3 and negative 1 half, it becomes positive 3 halves, and then we put negative 1 half at the side of e. Then we substitute based on the initial condition given. If t is 0, then the x prime is negative 2. So multiply all the numbers. Negative 3 times 0 is 0, and observe that we have only 3 terms left because the term with 3 halves times 0 is gone because it's times 0. And then we change all the e to the 0 by 1, so it's gone. So we're left with this, but we still have negative 1 half that can be transposed to the other side. So let's copy it because we don't have enough space, and let's transpose. So combined we'll have negative 3 halves. And then we divide all by negative 1 to make it positive. So this is the equation. So another equation we needed to solve for the constants c1 and c2. So let's have the equations that we able to come up. 1 half equals c1 plus c2 and 3 halves equals 3c1 plus c2. So I want to remove the c2, so I'm going to multiply negative 1 to one of the equations. I'll just choose the blue one. So distribute the negative 1, it will change the signs and copy the orange equation. Then we combine. So negative 1 half plus 3 halves, that will be 1. Negative 1 c1 plus 3c1 is 2c1. And c2 will be 0. Then divide both by 2. So c1 is 1 half. Now to find c2, we need, you can just choose either of the equations, but I will just use both. So let's change c1 by 1 half and transpose 1 half. 1 half minus 1 half is 0. So c2 is 0. Now let us check if it's also 0 in the other equation. So change c1 by 1 half. So 3 times 1 half is 3 halves. Transpose 3 halves. So c2 is 0. So it's correct. c2 is 0. Now we're done with computing all the constants. So our c1 is 1 half and c2 is 0. So let's go back to our general solution for our x. And we'll substitute c1 by 1 half, c2 by 0. So the one with 0 will be gone. So 0 times e to the negative t will be gone. So we are left with this. So the general solution is x equals 1 half e to the negative 3t minus 1 half t e to the negative 3t. And that is the final answer. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button. And also, write the math topics you want to learn in the comment section.